In this video, we'll go into the concepts of note pitch and scales. To understand note pitch, we need to understand frequency of vibration. In the Western system of pitch, every note name is equal to a particular frequency of vibration. Middle C on the piano, for example, produces a vibration of 261 Hz or cycles per second. A discussion of frequency can be very extensive, so for now, just be aware that each instrument, whether a stringed instrument like a guitar or a brass instrument like a trumpet, produces a sound wave each time it plays a note, and that sound wave vibrates at a particular frequency. When the frequency of a particular note is doubled, we get a note exactly one octave higher. And similarly, when the frequency is halved, we get a note one octave lower. So the C below middle C would vibrate at around 130 cycles per second, whereas the C above middle C would vibrate at around 523 cycles per second. The reason the octave is so important for our discussion is that it gives us a framework within which to talk about scales. In our pitch system, each octave is divided into 12 equal steps. Equal meaning that the difference in frequency between each successive pitch across the octave is exactly the same. We call this equal temperament tuning. As a side note, some other cultures divide their octave into more than 12 steps, thereby giving them other notes that we don't find in our music. Now, the first scale we'll talk about is the chromatic scale. The chromatic scale uses every note in the octave. This is what the chromatic scale sounds like. As you can hear, this scale has a somewhat ambiguous character. Just in the same way that we talked about melodies having contour, scales can have contour. Yet this particular scale has kind of a meandering quality, which is due to the fact that each step of the scale is equal to every other step. There really is no center of gravity to this scale since every step is given equal importance. The chromatic scale, we can say, is built on a series of half steps or semitones from the bottom of the octave to the top of the octave. If we represent the scale with note names, this is how it would look. C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, B, and C. By the way, we use the term sharp, represented by this symbol, to denote a note that is half step higher than the preceding note. And we use the term flat, represented by this symbol, to denote a note half step lower than the following note. And if we visualize the same chromatic scale on the piano keyboard, it would look like this. The bottom note is a C, and the top note, or the octave above, is a C double in frequency. Every note or semitone between these two Cs would be played to get the chromatic scale. In order for scales to have interest and contour, we need to utilize whole steps as well as half steps. Whereas half steps are equal to one semitone, whole steps are equal to two semitones. So in this chromatic scale, to move a whole step away from C, we would skip the C sharp and jump directly to the D. With a combination of whole steps and half steps, we get the great variety of note combinations that have gained acceptance as scales in Western music. Every note name equals a particular frequency of vibration. An octave is a note doubled or halved in frequency. Each octave is divided into 12 equal steps. The chromatic scale uses every note in the octave. A sharp is a symbol used to denote a note half step higher than the preceding note. A flat is a symbol used to denote a note half step lower than the following note.